Don't become a victim of wire fraud. That's what we're going to be talking about in today's video. Hey folks, I'm Gene Delasalo with Audioholics. We have a very special guest, John Siu. How you doing, John? From Benchmark Media Systems. So I'm glad to have you on here to talk about cables because I've been very vocal about cables for years. I've been doing measurements, I've been debunking claims, I've been doing it all, for 25 years, right? But it's very rare that you get a manufacturer on here that's vocal about it as well, that's able to speak out about it. Either they don't want to speak out about it because they don't want to piss off their dealers, their retailers, or they just don't want to have negative publicity towards them, right? Really hard to get people to be truthful about something that's so simple, something like a piece of wire. We understand the properties of electronics. We understand how signals flow through wires. We understand conductors. This is not a mystery, especially when you're dealing with audio frequencies. And that's why I wanted to bring you on here. I wanted to get your perspective as well, because you guys are a very measurement intense company. You've got some of the lowest noise floor, lowest distortion audio playback gear. So if a cable makes a difference, it's going to be presentable or audible or measurable on your gear, because we're talking about electronics that have SINAD of 120 plus dB, which is sometimes better than the test gear that we're using to measure it.
Yeah, I mean, the test gear, lots of times we can measure 120, 140 dB below the level of the music. And so we've got very sophisticated test equipment. But lots of times the differences in cables are very, very small. But one thing that's really interesting is there's no topic, there's no component that's more controversial that people will swear that cables are a very important part of the system. I mean, they're a vital part of the system, but they get way more credit than they deserve. And we're going to look at that and look at the relative differences between, how much influence does your speaker cable have? How much do your cables have? How much influence does your power amplifier have? How much influence does your room have? And what I've done is I've put together a bunch of numbers of, looking at what kind of variations do we usually see from speakers, what kind of variations do we usually see from the listening room, what kind of variations do we see from the power amp, the preamplifier, and the DAC. And we're going to look at those comparisons to try to see the relative differences and the relative importance of those different parts of our listening room. And today I'm in our listening room, and we'll take a look around the listening room here as we get into this. But wire fraud, don't be a victim. Make sound investments. Elements of wire fraud, sometimes it's intentional, sometimes it's not intentional, but
John, what kills me about that is I agree with you. Sometimes these companies don't know better. Like if you look at some of these high-end audio companies, they don't have engineers. Despite all the crap that they put on their website, there are no degreed electrical engineers at these companies. They don't know basic physics. Yet they're using these physics terms. They're using subatomic physics to describe problems at audio frequencies as if they are in the know. Right. You can't do this from a textbook. Right. You can't learn this in college with a PhD in electrical engineering. This is way more complicated because you're dealing with listening.
Yeah. It's, they've got, some inside knowledge that the rest of us don't have, but, and so there are many people that build these cables and sell these cables that legitimately believe that these cables make a difference. But I would say that they're probably in the minority, that there's probably more of these manufacturers that know that it's complete BS, but it's a profitable business.
very profitable. The margins are sometimes
Yeah.
70 or 80%. And then like you go into a store like Best Buy, they get incentives from the big companies like AudioQuest to sell and promote and showcase their products. So this is all profit. In fact, I was at a CEDIA show years ago, and there was a big sign that says, get better profits here. If you're an installer, get your biggest profits here, with an arrow pointing down to transparent cable. That was their shtick. That was their marketing, to get the dealers to come in and become a transparent audio dealer, because you're going to get more profits on your installs.
Yeah. And there's very little service on cables. You know, once
I
in a
don't know,
while.
because if you listen to Paul McGowan, he thinks every 10 years or so you need to change your cables because they get old. I don't know how a cable
And you
gets
got to
old.
burn them in too. Don't forget
Yeah.
about that.
Yeah, interesting.
So anyway, so what I did is the first thing I want to look at is frequency response, because this is really the thing that speakers have, that cables have the biggest influence on. We've done a lot of measurement on various cables. Speaker cables are always going to have the most influence on the system. And how much influence do they have? We usually see no more than 0.1 dB variation in frequency response when the speaker cables are driving speakers. And I think you've seen similar results in the tests that you've done.
Yeah, so I took, just to give you an example, I took some AudioQuest Thunderbird cables. They're like $5,000 or $6,000 cables. I think they were 8 feet in length.
Mm-hmm.
And I took the cheapest zip cord you could buy at Home Depot for 12 gauge. And believe it or not, the zip cord from Home Depot measured better than the AudioQuest cable, because the AudioQuest cable had more inductance. And then that battery pack was acting like an RF antenna. So it was adding noise. It was picking up noise in the system. And I didn't understand why that was until I physically removed the battery pack. It wasn't the bias, that bogus DC bias that they put on the dielectric, which does nothing.
Yeah.
I mean, the battery never dies. I guess that's a good thing. But that battery pack was acting like an RF antenna, and you could see it above 100 kilohertz.
Was that a line level cable?
Speaker level
cable. Yeah.
So
and you were getting noise.
Driving,
you were getting noise from the speaker cable. That's
and that's across a load. That's across an 8-ohm speaker. It's not like it was an open circuit where it was acting like if you took that speaker load off, that noise got way worse.
Wow. So
that's an example. But again, even when I did that comparison, you're exactly right. At 20 kilohertz, it was about 1/10 of a dB difference. I had to zoom in on my scale just to see the difference. And I've done my own calculations. In fact, I have an article I did years ago for our speaker wire gauge. And I basically tell you, if you want to have less than 0.2 of a dB of insertion loss, meaning that frequency response doesn't vary more than 0.2 of a dB from 20 to 20 kilohertz, depending on the load of the speaker, whether it's 8 ohms or 4 ohms, look at the gauge of the cable. The gauge is everything, how much resistance the cable has. And I came up with this table, and I calculated the maximum length of each of those cables to have less than 0.2 of a dB of insertion loss. I mean, this is a sophomore in college electrical engineering can do this. It's very simple math.
Yep.
And it just baffles me that it's still a topic that we're discussing for 25 years.
Yeah. And it's interesting that you actually discovered a speaker cable that makes noise. I have never encountered that, but definitely we see small variations in frequency response.
Right.
And I did have one cable in here that was a $20,000 set of cables that were 2 separate cables that were basically like welding cables. 1,000 strands or something. Just wonderful cable, except that the 2 conductors are separated, and you could separate the conductors and see the frequency response change a little bit. But we're talking about small fractions of a decibel.
Yeah, your inductance goes up as your conductors get further apart. Your capacitance goes down. There was another cable example that I noticed that would cause problems with amplifiers and speakers, depending on the unity gain crossing of the amplifier and the impedance of the speaker. There was a company called GoHertz, where they sandwiched 2 flat conductors on top of each other, which was great in terms of giving you the lowest inductance possible. but without the Zobel network on the end where the speaker is, it could cause your amplifier to oscillate. So if you had a
Yeah.
really wide bandwidth amplifier, I would see the amplifier frequency peaking at 20 kilohertz and ringing without putting an RC network across the speaker load.
Yep. Yep. So,
But they're out of business, so maybe that's why. I don't know.
but even so, the difference between this $20,000 cable and the zip cord was still on the order of less than a tenth of a dB within reasonable frequency range. And so let's look at this chart. Right at the top is the impact of the room, and where I have the speakers in the room, the size of my room, the reflectivity of the walls of my room can make plus or minus 20 dB variations in my frequency response, especially in the bass response. You can get room modes where in one particular position in the room, I'm just getting blasted by this one bass note, but I move over to another position in the room and you can hardly hear it. And if you listen to somebody running up and down, walking up and down bass, some notes will blow you out of the room, and some notes will just be swallowed by the room. And so we can see large variations. We've moved these speakers here around in this room and encountered major variations in the frequency response at the listening position. And we know that from running room correction system and acquiring measurements using 17 different measurement locations within the room and averaging between them, and just the position of the speakers in the room, the treatment of the room is all very important. Speakers themselves, very often plus or minus 10 dB frequency variation across the limited range of the speaker. So we're not talking about going all the way down to 20 hertz, down to the reasonable low end of the speaker within its band pass. You often see plus or minus 10 dB peaks and valleys in the frequency response. Better speakers like these are much better than that, but
yeah, you could get speakers that are plus or minus 2 dB anechoic, but when you stick them in a room is when it really starts to go to hell.
Right.
Yeah.
So let's compare that to power amplifiers. You know, any halfway decent power amplifier is going to be within 1 dB between 20 and 20 kilohertz. You will see some Class Ds that have peaks in the response just before they roll off above 20 kilohertz. So that's something we encounter sometimes with when we look at Class D amplifiers. But generally, you're going to be somewhere in that neighborhood of plus or minus 1 dB. If you're talking about a benchmark AHB2, we're plus 0 minus 0.2 dB. Preamplifiers, they're generally a little bit better than power amplifiers. I would say plus or minus 0.5 dB is pretty typical. If you're talking about a benchmark LA4, we're plus 0 minus 0.001 dB. So absolutely ruler flat on both of those two items, the power amplifier and the preamplifier from benchmark. DACs again are these days are all better than plus or minus 0.5 dB for a decent DAC. You know, unless they've intentionally tried to color the response.
Mm-hmm.
And we've seen a few DACs that have come on the market that have got a bass boost in them and various things. But
well, I've seen that with phono preamps too. Phono preamps
yeah.
can vary on bass. Some of them roll off below 20 hertz, some of them don't. So, I mean, there's big variances there as well.
And then down below all those, we have speaker cables where we're seeing 0.1 dB variations at worst case. And if we talk about line level cables, XLR cables, RCA cables, the differences there are less to do with the cables themselves and more to do with the drive impedance. So
Yeah.
if you have an output impedance of 600 ohms, you're going to see a roll off of the high frequencies. But if you have a 60 ohm or 40 ohm drive impedance, like we build into all of our products, the cable capacitance really becomes a non-issue, and you end up with a very flat frequency response out to 500 kilohertz or so.
And it's important to note, if you're dealing with line level cables, you look at something like a Belden 1694A. That's a broadcast standard quality coax, cross coax, double braided, double foil shielded, good to from DC to 3 gigahertz.
Yeah.
3 gigahertz. And it's not expensive.
No. And the note at the bottom is that 1 dB is about a just noticeable difference in level. Lots of times it's a just noticeable difference in frequency response. The point being that the variation from the speakers, the speaker cables rather, is probably well below the threshold of detection. But look at the impact of the room, plus or minus 20 dB or so. And the interesting thing is that if I move my head a little bit, or if I move my measurement microphone, we'll see major changes in the frequency response at that one location. And so if you can imagine, I'm going to switch out a pair of speaker cables. I'm going to walk up to the front of the room. I'm going to change my speaker cables, and I'm going to plunk myself back down in my easy chair. Is my head sitting in the same position it was? Have I moved a little bit? What am I, and what are my expectations? I'm expecting to hear something different because I changed out these cables. And so it's very easy to think we're hearing a difference when we try some of these poorly controlled tests of, swapping out cables.
Yeah, and that's the biggest problem right there. Someone just asked, I believe in measurements, but how do you explain when you change nothing but the speaker cable and the length and the gauge, and all of a sudden it sounds more revealing than the other? My answer to that is you've got expectation bias and placebo effect.
Yeah.
Because if you're not doing an instantaneous blind comparison in a controlled manner, and someone just goes and changes the cable, you're automatically going to expect a difference, right?
Yeah.
And you're listening, your brain is not that good at memorizing sound if it's not an instantaneous comparison. So if there's a 3 or 4 second switch over time between the cables, you're going to think it sounds different just because you know that there's a change. And that's the biggest thing about cables is, look, I'm not discouraging people to spend money on nice looking cables to dress up their system. And in fact, looking at it gives you pleasure. So it puts you in a better mood. You might enjoy the experience better. I like seeing big VU meters on amplifiers, even though it doesn't change the audio at all, but it's a visual cue that gives you more enjoyment with that. Just like when you buy a speaker that has really nice cabinetry or a nice finish.
Yeah.
It's just the visual presentation is more to do with what people think that they're hearing and differences in cables rather than the actual electrical properties themselves.
Right. A good analogy is people buy watches and collect watches because they like the way they look, they like the way they're built, but not because they're more accurate at timekeeping. It's just a fun thing to collect. It's a fun thing to look at. And so yeah, there's merit from that standpoint, but don't go into it with the expectation that they're going to sound different.
Yep.
So Next slide here is just looking at noise. Now, I think you found the speaker cables that are the exception to the rule. I have never found a speaker cable that created noise. So on my chart, I say speaker cables always create much less than 0 dB SPL at the output of the speakers. Obviously, you found that this cable with a built-in battery, you know, and obviously the energy from the battery
at ultrasonic frequencies
was capable of doing something.
Yep.
But let's just talk about noise in the room. A typical living room is going to be about 40 dB SPL. This room here, we're about 28 dB SPL in our listening room. Gets a little noisier when more activity is going on in the building, but we're usually right around 30 dB SPL. Speakers sitting here in the room, hopefully, are not making any noise. And typical power amplifier, if you do all the math and go through the calculations of the signal to noise ratio and the output power and so forth. And I went through a lot of amplifiers, and to come out with typical numbers about really close to you know, the low 0 to 10 dB SPL is about the noise that's going to be coming out of your speakers from your power amplifier. Some power amplifiers are better than that, and you'll hear no noise coming out of your speakers. Some power amplifiers are considerably noisier than that, but
the high gain ones especially. Yeah,
but amongst reasonably good power amplifiers, those are relatively typical numbers. If you look at a benchmark AHB2, hook it up to a pair of speakers, the output noise is going to be minus 22 dB SPL at 1 meter from the speaker. You know, 22 decibels below the threshold of hearing. So that's the state of the art right now. Preamplifier, a lot of times the contribution from the preamplifier is about the same as the power amplifier. In the case of the benchmark LA4 preamplifier, we're 25 decibels below 0 dB SPL, 25 decibels below the threshold of hearing. And a DAC, lots of times you'll get a little bit of noise contribution from the DAC as well. But in the state of the art, there is going to be 14 dB below the threshold of hearing. So all of the electronics have the capability of being noise free. And this speaker behind me right now, that's being driven by an AHB2 in bridge mono, puts out over 400 watts into these 4-ohm speakers. It's being driven by, let me zoom out here so you can see it. I've got a benchmark LA4.
Yep.
Hooked up, there's a benchmark DAC 3B driving the LA4, and that's connected to AHB2 running in bridge mono, and the LA4 is sitting at 0 dB gain, so we got the full output of the DAC going into the power amplifier. So if I were to hit play right now, it would blow us out of the room. You know, we'd have 120 decibel sound coming out of the speaker right behind me. But I can walk up here, and it's dead quiet.
Wow. Now you don't even have your cables lifted off the floor. They're actually there's no elevators. Why no elevators?
Oh, I forgot those. Yeah. Apologize for that.
So that's a very good point that you bring up. Number one is you have a very quiet room, much quieter than a typical living room. When you have a quieter room, like in your case, it's almost 20 dB below the average room in a house. that preserves your system dynamic range. It actually increases it. You don't have to listen as loud to get the same kind of dynamic range and same output. And you get to hear the more subtle details. It's not masked by room noise.
Right.
Then you've got the electronics that are not adding thermal noise. They're not adding hiss. So you're getting the most transparent playback system that's possible.
Yep.
So again, if the cables made a difference, this is the kind of setup that you would potentially hear that on. But as you noted, we're talking about 1/10 of a dB difference between the worst cables and just regular lamp cord cables, which is sonically indistinguishable.
Yeah. Now, let me give you a good rule of thumb, and that is that your ears have the ability to hear about 30 decibels below white noise. So if your room is at 40 dB SPL and it's white noise, you can actually hear music that's playing at 10 dB SPL.
Mm-hmm.
And if your room is at 30 dB SPL, you should be able to hear music all the way down to 0 dB SPL. And so, you know, a lot of times people think that, well, my room noise is 40 dB SPL. I can't hear anything below that level. Or I have a 16-bit audio system that's got 96 dB signal to noise ratio, and I can't hear anything below that level. Well, that's not true. You can hear 30 decibels below a white noise signal. Now, if the noise in your room is a buzz or a sound of a motor running or sound of a fan running, it may have more of a masking effect than something that's more benign like white noise.
Right. Got to answer this question real quick here. It says, Gene, why 4-ohm speakers available than 8-ohm speakers? The answer to that is several reasons. When you're dealing with speakers with multiple drivers and you put a bunch of bass drivers in parallel with each other, it's going to lower the impedance of the speaker. And most tower speakers, even though the manufacturer says 8-ohm nominal, if you look at the IEC standard for measuring loudspeakers impedance from 300 hertz to 3 kilohertz, if it's an 8-ohm speaker, it can't drop below 80% of that, or 6.4 ohms. For 4 ohms, it can't drop below 3.2. It's very rare that I see tower speakers that are 8-ohm. Even though the manufacturer claims it, they always are right around 6 ohms or 4 ohms, which is why it's important to have an amplifier that has the current drive to be able to handle, you know, the lower impedance loads like that.
Yep. Another issue is distortion, and again, you're not generally going to see distortion from the cables themselves. Now, if you've got a nonlinear load like speakers on the end of the speaker cables, and the speaker cables have a resistance, a series resistance, yes, you will measure distortion at the end of the cable. So, but that's not distortion caused by the cable itself. It's it's because of the series resistance. So I wanted to qualify that a little bit, but do we get distortion from the room? And the answer is yes, sometimes. If you've got a ceiling tile that's vibrating, or you've got a lamp that vibrates, all of these things are causing distortion when the music's playing. So it's real important to try to get rid of all those things that are buzzing and rattling in your listening room. Speakers, 2% distortion, 4% distortion, 6% distortion. Those are rather typical numbers. What does that mean in terms of decibels? 2% distortion is just 34 dB below your music. Okay, so if your music is hitting 105 dB SPL on the peaks, which is the THX level, you know, that they to qualify a system, they want to see that the system is able to do 105 dB SPL. That means that that the distortion from the speakers is 71 dB SPL. Now, that's about the noise created by a washer machine. So it's like having a washer machine sitting in your listening room. The distortion from your speakers is that loud. Now, obviously, the distortion from the speakers is not machine noise like the washer machine. It's harmonically related to the music. So it's not non-musical, but it does very definitely change the way the instruments sound. So
and that's why it's important when
yeah, go ahead.
When you're picking loudspeakers, because there are exceptions to this. There are speakers that are lower distortion than this, like the per listen stuff, for example.
Yes.
They just, when you get a speaker that has really good drivers, incredibly executed crossovers, lots of piston area, lots of cone area, not just in the bass drivers, but in the mids, and less compression. So you have a tweeter that has thermal capability of not compressing at high output. Those distortion numbers drop, but it's still not as down to the levels of electronics, the best electronics, especially. Right. The limiting factor is the room and the loudspeaker in this case for distortion and noise.
Now, as far as power amplifiers are concerned, it's real typical to see about 0.01% distortion at 1 watt to 2 watts, 3 watts, typical levels. Obviously, at full power, all of the amplifiers are normally rated at 1% distortion. Well, you don't want to listen at 1% distortion. We're way up in those. We're minus 40 dB is 1% distortion. So at that point, the power amplifier is rivaling the distortion of the speakers themselves. But at 0.01% distortion, we're talking about a level that's 80 decibels below the music. So if we're listening at 105 dB SPL, that's 25 dB SPL is the level of the distortion produced by a typical power amplifier. That means that it's considerably above the threshold of hearing. Whether we can hear it or not depends on the musical content, the nature of the distortion, and a whole bunch of other factors. But the point is, it's high enough to be heard. And so if you look at what happens if you put a benchmark AHB2 in, RTHD is 120 decibels below the music. And that means that in the listening room, when we're playing at 105 dB SPL, the distortion is 15 dB below the threshold of hearing. So absolutely inaudible. So there's no audible noise, or no audible distortion, rather, from the benchmark power amplifier in this particular scenario. Preamplifier. Preamplifiers are generally lower distortion than power amplifiers. If a preamplifier has a 0.003% THD specification, that means that the THD is 90 dB below the music, which would be 15 dB SPL at the 105 dB listening level. In the case of the benchmark LA4, we're talking 126 dB below the music, which means that the distortion produced by an LA4 preamplifier is minus 21 dB SPL. Again, completely inaudible, but it can be audible depending on what preamplifier you choose. So you can see the choices we make in power amplifiers and preamplifiers and speakers are going to have a big impact on how loud the distortion is going to be in my room.
Right. We got a quick question here. I just wanted to bring this up. That's about cables. Is there a possible advantage of very small degree of silver speaker wire over copper? So silver is about 10 to 15% more conductive than copper. Yes. So my answer to that is just add more copper and save yourself money. Don't buy the silver.
It's it's 110% of the conductivity of copper.
Right.
So
And it's important to note, don't use copper-clad aluminum because that's garbage. The
yeah,
conductivity of that is not as good as regular pure copper. It's cheap to buy pure copper. Make sure you buy an oxygen-free cable, pure copper. I always recommend 10 to 12 gauge, regardless of the length, even if it's a short length. I know there's people that say, oh, I use 14 gauge. You could use 14 gauge. But if you're doing 30, 40-foot runs of cable and your speakers are 4 ohm, stick with the 10 or 12 gauge
yeah,
or 14.4
yep.
and parallel them. 14.4 parallel gives you 11 gauge effective resistance.
So as far as distortion from cables themselves, you know, I've never measured a cable that created distortion. You see all this nonsense in the advertisements for cables about
diode rectification,
the type of insulation,
Yeah.
the spacing of the conductors, reducing the distortion, and all kinds of pseudo-scientific mumbo jumbo, and it just doesn't happen.
They try to make it look like a piece of wire can behave non-linearly, which is impossible for that to happen. There's no diode rectification in a cable. There's no polarity in a piece of wire. And I've measured interconnects. I've measured cables, speaker cables, you name it. And like you said, I can't measure any distortion. And that's with an audio precision that's good to 120 plus dB. So if there was distortion, you'd be able to see it on that.
And the ultimate nonsense is fuses.
Oh God.
You know, and some of those are they claim that they're directional and that they need to be burned in, and you know, next year they're going to have a better one, and you know,
they put a sticker on a Home Depot fuse. They have a purple sticker, they have an orange sticker, and they sell these Home Depot fuses that are $2 or $3 a pop for $200 or $300 a pop.
Yes,
and they offer you a money back guarantee.
Yeah. Yeah.
I like the movie Tommy Boy. You could get a good look at a T-bone if you stick your head up a cow's ass, but I just take a butcher's word on it. That's my response to that.
So what is you know, what's the conclusion of you know, of all this is that, you know, here's a upgrade priority list. The number one priority has got to be your listening room. You know, are you treating the walls of the room? Are you getting rid of the sources of noise in the room? Are you getting rid of things that vibrate, that rattle? What about your speaker placement? Where are you placing the speakers in the room? All of those things are a big factor. Are you using a room correction system? And I'd highly recommend using a room correction system like Dirac. We use Dirac here, and we actually need very, very little correction in this room. When I turn it on and off in this particular room, there's very little change. We've got another listening room here where we've got different speakers that are not nearly as flat as these PMCs. We've got some Westlake studio monitors in the other room, and they need quite a bit of correction. I suspect that they always did, but that was normally done as part of a studio installation. So room correction, room treatment is a big deal. In fact, let me show you what we've done in this room. If you can put the other screen up there for a second. I'm just gonna show you, oops, I'm sorry, wrong button. So if we look around the room here, you can see that we've got treatment on the walls. Those are 2-inch thick absorbers on the wall. Up here, we've got corner absorbers at the junction of the wall and the ceiling. And we have more of those on the vertical corners. and on the ceiling. We've got panels on the ceiling as well. And what you can't see is that behind this benchmark screen that's behind me, that whole front wall is completely covered with absorbers.
Yeah, and I do something similar in a home theater room when you have an acoustically transparent screen. I put absorption behind the screen,
Mm-hmm.
and that actually helps tame out the mid-bass upper frequency area, cleans that up a little bit, and you get a much stronger phantom center that way. I mean, I just could not believe when I made that change.
That is the biggest thing about treating the front wall is what it does for the 3D image that you have in that phantom center and the sense of depth. That's completely destroyed if you've got reflections coming off the front wall.
Yeah.
And the closer you move your speakers to the front wall, the less of that 3D effect you'll have.
Yeah.
You can't really tell from this view here, but these speakers are a good 6 feet off of the front wall.
Yeah, and you got to be careful, because if you don't put the speakers out far enough, you get speaker boundary interference and you get big dips in the bass. So the way to overcome that is to either add subs at the front of the wall, or to put some really thick absorbers on that front wall to help minimize SBIR effects, because the SBIR could get pretty bad, especially in my room. I have it at 80 hertz. It's very audible at 80 hertz. And the only way I could fix that, I couldn't move the speakers. I had to add more subs.
Yep. And there's another approach, which is to actually put the speakers into the wall, flush with the wall, soffit mounted. And a lot of studios were built that way, where the big speakers were mounted flush right into the wall.
I just don't feel like you get the same holographic imaging when you do that, though, as you do with a speaker out in the room. I think there's pros and cons. You solve SBIR with an in-wall flush mount product, but you lose that perception of depth.
I agree. And you can come into this room and you can sit here and listen, and you'd swear that the musicians are back. Whoops, I'm sorry, hit the wrong button again. Back there behind that screen, and it's a wonderful effect, and you don't get that effect when the speakers are close to that front wall.
Right. Now, let me ask you this, John. What cables do you typically recommend? And don't you guys have some cable products, don't you? You do some cable.
So I've got a very short version of our speaker cables. These are locking banana plugs on this end, which I like a lot better than spades. One of the problems with spades is when the cable moves like this on the back of the speakers, they loosen up, and a loose connection will cause distortion. And so these locking bananas go in very tight, and you don't get distortion across this connection.
Less contact resistance too. You're minimizing
contact resistance, and really it's that intermittent change in the contact resistance that causes the distortion, and we can measure that quite easily. But a good, clean, tight connection with these locking bananas does the job. The other connector that works very well for speakers are these speak-on connectors.
Speak-on, yeah.
These are a professional connection that's used for big sound reinforcement systems. We've introduced these to the hi-fi market with the AHB2. We have these on the back of the AHB2. You don't get any distortion due to the contact resistance on these. They're phenomenal. They work very well. The locking bananas work very well. The spades, not so much. One thing that you don't want to use are these spring-loaded banana plugs.
Oh yeah,
they're dreadful. And it's very easy to measure the distortion across that connection. So stay away from spring-loaded bananas. The The other cables that we have are XLR cables. Most important thing is good connectors on the end. These are Neutrik gold contact connectors. The reason for the gold contact is they stay corrosion free, and you always get a good reliable connection. They also have wonderful strain relief on them. If you look at what any pro sound company is using, it's almost exclusively Neutrik connectors.
Yep.
The cable that I like the best is the Canary L4E6S, which is it's a star quad cable, which means that this cable is immune to magnetic interference. So if this is laying across the top of a big power amplifier, or it's laying across a fluorescent light, or it's laying across a wall wart, it's not going to pick up hum or buzz or anything. It actually picks it up equally with both the plus and minus conductors, but because that interference is exactly the same on both the plus and the minus, it gets taken out by the balanced input receiver. So the big advantage of star quad is immunity to magnetic fields, and it's not expensive. And this feels really nice. It's got a very nice jacket on
flexible.
it. It's flexible. It's about 20 decibels better at rejecting magnetic interference than the Belden cable. And Mogami cable, I mean. It's about 20 decibels better than the Mogami Star Quad. We have, various adapter cables. This is a balanced to unbalanced adapter cable for using with the Benchmark AHB2. The Benchmark AHB2 does not have RCA inputs on it. That's intentional. If you've got something with an RCA output, if you got a preamplifier with an RCA output, you really need to buy a different preamplifier, because that's going to be by far the limiting factor in your system if you've got a Benchmark AHB2 power amplifier. So,
gotcha.
We can give you a cable that'll allow you to use it with an unbalanced output, but that's you've really got a mismatch between.
Yeah, you're losing about 6 dB of potential SNR benefit of the balance.
Yeah, right.
Yep. Well, John, I appreciate you coming out here and being brave and talking about cables. So
and I know the hate mail will come in, but it did the last time we talked about cables. The last time I did an app note on cables, get all of these. Some is outright hate mail. Some of it's just, but it's all these anecdotal. But I did this, and I've
got one up on you. I've been threatened with lawsuits. I've been stalked by cable companies. It gets ugly just because I'm sitting here talking and showing measurements and saying that most of the marketing claims using engineering terms are garbage. But people get hertfilioma. So I'm just going to keep doing what I'm doing. I've been doing it for 25 years.
Yeah, I mean, we shoot straight. Benchmark. That's what we do. We shoot straight, and you gotta call these things out sometimes.
I like the fact that you emphasize how important the room is, how important speaker placement is, as well as seating position, because that's positional EQ right there. Getting a good bass management system with multi-sub will help tame a lot of those bass problems you were talking about.
Yes.
Room correction, after you dial in the room acoustics, the room correction is just the icing on the cake. That's the last and final step. And then listening, because you can make a curve that's flat or it looks good, but sometimes if you don't get the house curve right, if you don't have enough bass tilt up, things will sound too thin, too bright. It just won't sound right. So ultimately, listening after you're done calibrating and making adjustments to your seating, making adjustments to positioning of your speakers, your EQ, all that stuff. Those are the things that really make a difference.
Yeah. Yeah.
And then last, get the light control in your room right, because if you listen in a bright room versus a nicely dimly lit room with good ambient lighting, it puts your whole brain in a different focus so you can concentrate on the music.
Yeah. Yeah.
So anyways, I am going to link up some of your app notes in the video description below. I'm also going to link up the prior live streams that we did with Benchmark. We did a great one on amplifier, preamplifier gain matching. I suggest you guys take a look at that, because that's incredibly important to make sure you have the right gains between the stages to minimize your noise and lower your distortion and all that stuff. I did a video recently about that as well with receiver preamp output voltages. I do encourage you guys to take a look at that as well. So John, I appreciate you. We will be back again. What's the next topic we're going to explore on our next live stream?
Oh, that's still in the works.
In the works. Okay.
In the
well,
works.
guys, give us some suggestions. If you
in the meantime, don't fall victim to wire fraud.
Don't. Yes. If you're buying the cable because you like the look, just don't buy it because you're buying some stories that's based on half truths or no truths, and spending all that money because you promise a better sound or better whatever.
Instead of making investments in cables, make sound investments. Invest in your room, in your speakers, and in your electronics. But the last thing on your list should be the cables.
And this is another good point. Dedicated circuits make a huge difference. I isolated all the grounds in my theater room. I put a sub panel and I put a device on there. That's a commercial grade device from a company called Surge Pure. And the noise floor in my system dropped. And I have to do a video on it. I'm just a little bit backlogged, but that made a huge difference, is to get rid of all the nonsense my builder did a really poor job with the electrical wiring of my house. So I just had it completely done just for the theater room. Huge difference. Got rid of ground loops, got rid of noise, all that stuff. That makes a big difference. And that's a very important point that this person, Kevin, made. So guys, if you like this video, please hit thumb up, hit subscribe. Don't forget about our Patreon channel at patreon.com/audioholics. We appreciate your support. You get direct access to me if you want to suggest video topics. And until next time, my friends, keep listening.